Hey everybody, welcome to the Applications of Derivatives exam answer key. So let's go ahead and get started on this because we've got lots to do. Okay, so let's look. Our first function, our first question, what are the values of x for which our function y equals, y equals x cubed minus 6x squared is concave down. So concave down, what does that mean? Well, that means your second derivative. In this case is less than, well, in all cases less than 0. So what are we going to do? We're going to start with the derivative. Okay, so you're going to go ahead and take the derivative of your function, which is y prime is going to equal 3x squared minus 12x. We want second derivative, so take the derivative of your derivative and you get 6x minus 12. Okay, now what you're going to do to determine concavity, we need the zeros. So we're going to look for the possible points of inflection, and I'm going to go ahead and do that, and I'm going to factor out the 6 now, and I get x minus 2. So what makes this all 0? Well, that's when x equals 2. So I can start to eliminate some answers here, here, and well, between 0 and 4, I'm going to get rid of that too. So x equals 2. So we need a sign analysis. Let's figure out what's going on. So 2 is my 0 on the AP Calc time. They put 0 there sometimes. That 0 is not needed. I'm going to put x minus 2 here. And I know if I plug in any value greater than 2, this whole thing is positive. If I plug in any value less than 2 in here, it's negative. Okay, so this is where your function is going to be, your second derivative is negative, so it's less than 2. That's where your function is going to be concave down, so your answer is C. Okay, let's keep moving on. All right, number 2, if y equals the natural log of 3x plus 5, then find the second derivative. That's what that squared means up there, the second derivative. Okay, so I need to find the second derivative of this, which the first derivative is no problem. You take the first derivative. For natural log, you take the derivative of the inside, which is 3, over the bottom, just the bottom. Okay, now look what we have here for the answer. Look, there's the answer for our first derivative. This is gone. It's our first derivative answer. Second derivative, you can use quotient rule if you want. Bottom times the derivative of the top. The derivative of any constant is 0 minus top times derivative of the bottom, which is just 3, all over your bottom squared. Okay, so here's what you can do. You can start eliminating more choices. This is all 0. Minus 3 times 3, so minus 9. I need a minus 9 on top. So boom, that's gone, that's gone, that's gone. It's got to be negative. So there's your answer. Your answer choice is D. Okay, moving on. I love number 3. Okay, so you have this function. You have the derivative. Big important thing here. Derivative function. Okay, that's key. You're going to figure out which value is largest. This is a twice differentiable function. F of 1, let's highlight some important stuff here. F of 1 equals negative 2. So how do you do this? Well, start with what you know. You know that F prime of 2, which is right here, the value there is 0. I know that. Okay, I also can find f double prime of 2. Okay, this is a first derivative, so if I take the tangent line, there's second derivative, so it's increasing, so f double prime of x is greater than 0. So f of 2, at that point, it's a positive slope, is greater than 0. So far we know that f double prime should be greater than f prime. So it works for A, does not work here. F prime is smaller. It could work on C, can't work on D. F prime is not bigger than F double prime, and it could work on E. So I've got 3 choices left. So what's going on with F of 2? Well, F of 2, you guys, is at 2, you're going from a negative value on your slope to a positive. That's a minimum. It's the smallest value. It's lower than negative 2. It's smaller than negative 2, making it smaller than f prime of 2, making it smaller than f double prime. So the only logical conclusion here is A. So number 3 is A. Okay, let's look at number 4. The mean value theorem. Okay, the mean value theorem says there's some number C which is going to equal to f of B minus f of a all over b minus a. What it says is that there's a value for c that is going to equal, there's going to be a derivative at some point c that's equal to the slope of the secant line. So there's some value of c that's going to have the same slope as the secant line here of the endpoints. All right, we're back. So our function here is x cubed. Okay, so we have our function f cubed. Here's our interval. Okay, so we know that, we know that a is going to equal -1, b equals 2. So we're going to say that f prime of x, find the derivative, that's equal to 3x squared. Okay, so they're saying now that there exists some value. It's a continuous function, it's a polynomial, it's definitely continuous, so we're okay there. There's going to be some value c that's going to give us a derivative, a slope of a tangent line, that's going to be equal to f of your b value, f of 2, minus f of -1 over 2 minus -1. Okay, so bell done. We're going to say that 3c squared, that's f prime of c, is going to equal f of 2, which is 8, right? 2 cubed, minus -1, which is +1, all over 3. So 3c squared is going to equal 9 over 3. 3c squared equals 3. Solving this, you get c equals plus or minus 1. But remember, it's, yes, the mean value theorem on the closed interval, but it's differentiable on the open interval. So it's going to eliminate d, this one, this one, this one. It's put down to b and d, but because you have to be on the open interval, it's only going to be b. Okay? Number 5, the mean value theorem does not apply. Does not apply to this function because, well, let's look. Which is it? That's an absolute value function, so that function is continuous. However, it is not differentiable at 3, okay, because it's a point. So it is not differentiable at 3. Your answer choice is B. We skipped 6, and number 7, okay, you're looking for the particle is moving right. Okay, which of the following are true about the particle? Starts at t equals 0. T equals 0. Okay, here's your position function. Okay, when is it moving right? Is it at rest? Changes direction. Okay, moving right. F prime of x greater than 0. Rest, f prime of x equals 0, and then changes direction, we'll see. Okay, so you need the derivative. So f s prime of t, you have first times the derivative of the second. So you have first t minus 2 cubed times derivative of the second, which is just 1, plus second times derivative of the first, which is a chain rule, 3 times 2, t minus 2 squared times 1. I can't fit the times 1 there. There we go. Now, how do you deal with this? Well, let's look. You've got, let's get a different color here. You've got t minus 2 here. You've got t minus 2 here. Factor it out. So this is a tough one. So you're going to factor out t minus 2 squared, which only leaves us now, in this first part, a t minus 2. You factored out both of these, you're going to have plus a 3 times t minus 6. Okay? So you get t minus 2 squared times, well, you get t minus 2 plus 3t minus 18. Okay? So that becomes t minus 2 squared times 4t minus 20, which is now t minus 2 squared, factor out the 4, and you get t minus 5. Oof. So, sign analysis time. You got 2, we've got 5, and you've got t minus 2 squared and you've got t minus 5. Okay, so let's look. Now, when anything's greater than 2, it doesn't matter what's in here. The combination is always going to be positive. Okay, now if you did these separately, like a t minus 2, t minus 2, be careful, but I just put them together. This is all positive. Doesn't matter. You put any number in here. It has to be greater than 5 to be a positive, so these are negatives. So the derivative here, positive, negative, negative. So the particle's moving right for t greater than or equal to 5. It is. Okay, the particle's at rest at t equals 2 and t equals 6. It's not. It's rest at 5 and 2. The particle changes direction at 2. It doesn't. You go negative, negative, doesn't change direction. Your answer there is A only. Okay, so that was a tricky one on number 7. So